In this video, I'm just going to describe the basics of step growth polymerization, starting out by presenting an example where we have an acid where the R group is some additional structure, but not writing it out just to make it easier to visualize. Likewise, R2 is a different structure. The acid and the amine react to make water and to form this bigger molecule. Important thing to realize that this R1 and R2 still have reactive groups, so in step growth polymerization, these can continue to react. This particular type of step growth polymerization is also called a condensation reaction. We make water as a small molecule product. Now the general form of the reactions are, for example, an AA and a BB structure, where the A and the B have reactive groups so that A and B can react. This is still reactive and this is still reactive, so they can continue to react to make larger molecules by A and the B reacting. And two of these can react and larger groups can also continue to react. The other type of reactions where the same molecule reacts with itself, it has different functional groups, and so it can form larger molecule where again the A and the B are still reactive. So essentially in these step growth polymerizations, all the species can react with each other. The polymers can continue to grow. Their lifetime is long if we want to contrast it to addition polymerization. And usually when we have these, we have chains that form, so we form polymer chains that have heteroatom. And see what we mean by that is we have carbon and a nitrogen, this chain that's going to continue to grow, whereas many of the addition polymerizations, for example, may be all carbon atoms in a structure. So here's an example of step growth polymerization without any condensation, no small molecule is formed. As we have two reactive groups on this molecule and then two reactive groups on this molecule. The OH, the oxygen, reacts, so hydrogen ends up here. Notice we have this heteroatom backbone of carbon, oxygen, nitrogen, and then these can continue to react. They could react with another one of these species or these species, or two that look like this, and likewise with bigger ones, and this would then make polyurethane, step growth polymerization. So the reactions, the kinetics, the products they form are quite different from the addition polymerization reactions.